Looks like we're subtracting these polynomials, and the minus sign is not going to have any effect on this first trinomial right there. In any case, though, really what I would like to do is take that first trinomial there, and I pretty much just want to ignore it. So let's go ahead and just kind of cover that up. It's there, like, you see what I'm saying? Like, I'm not saying it's not there. I'm just saying I don't really care about it right now because this minus sign is only applicable to this second trinomial right there. And yes, I would look at this as a -1 that I will then distribute into all three terms of that trinomial. And by distribute, I mean multiply. Yeah, but it says subtract, right? Yeah, that's because I haven't looked at this other polynomial yet. We'll get to it. So I've got a -1, start there, -1 multiplied by the 4x to the power 5. And yes, distribution is just another way to say multiply. So a -1 times 4 is going to give me -4. That's how many x to the power 5s I've got. Then we've got a -1 times a -9x squared, because the 9 right there will take the operation to its left as its sign, which will end up being a positive 9x squareds. And then the last distribution, -1 times the 8, will end up being a -8. Okay, so that's my first, or that's the second polynomial after the distribution. Now, if you noticed that all we really did with this minus sign is change the signs of each of the three terms from a positive 4x to the power 5 to a negative 4x to the power 5, from a negative 9x squared to a positive 9x squared, and a positive 8 to a -8. That's fine too. It still works. It's the same thing. It's just kind of explained in a different way. But at this point, I can look at this first polynomial right here, the trinomial, and let's go and bring that down so that we can look at these and combine them. And at this point, I'll say, remember that I don't really need the set of parentheses for this first trinomial because there's nothing to distribute other than what would be a +1. So we can get rid of that. Now, why am I getting rid of it? It's so that there's no barriers for me and my combining of like terms. All right, so let's go ahead and get started then. My first term on the left, because I like to scan these from left to right, is an x to the power of 5. So I've got an x to the power of 5. How many of those will I have? Well, scanning from left to right, I've got an x squared. That's not a like term because the exponents are different. Same with the x. Again, it's the same base, but the exponent is different right there. That exponent would be a +1, which we don't necessarily like to show, but you can. But the next term, -4x to the power 5, yes, this one is a like term. And so we'll just kind of note that. Continuing though, positive 9x squared, not a like term because the exponent's 2, and then the constant -8. So how many x to the power 5s will I end up with? Well, it's +6 minus 4 is 2x to the power 5s. And that takes care of those two like terms. The next like terms I've got, I would be looking for -5x squared, and the next one I can see is that positive 9x squared. So how many x squareds will I end up with? Well, it's -5 plus 9, which would be +4. Now, you notice that I'm writing the positive sign in as the plus sign. That's on purpose because every term will take the operation to its left as its sign. Now, we do have two other terms, but look at this one right here. We got the -6x right there. The -8 is not a like term with it, so I'm just going to write that separately. -6x right there, and also the -8. No other constant like terms to combine with it. So I'm just going to write that out. So we ended up with 4 different terms that are not like terms. They're different terms, right? And there's nothing else I can really do with this one. You'll keep in mind as well that the order does not really matter here. What does matter is that the signs of each of the terms are the same. For example, if you have the 8 right here, which is negative, if you put it over here, it needs to show as -8 to indicate that the 8 is still negative. Okay, so keep your signs the same, and you can jumble this, you can mix it up a little bit. The values have to be the same and the signs have to be the same. That's all that matters. Later on, though, in like a Math 1010 class, they're going to say, hey, you need to make sure that these are in descending order, which this is. When they say descending order, they're just saying you want the exponents to get smaller as you go. And these ones do, but that's not really something we need to worry about. So this one's done. Thanks for watching, you guys. We'll see you in the next one.